Hi, everybody. My name is Faraz Taifes Matian. I'm a technical marketing engineer with the Cisco's Cloud Networking Group. And today, I'm happy to be here to talk to you about the latest and greatest 400 gig capable additions to our NOK-X 9000 switch portfolio. So what are we trying to addressing with higher bandwidth platforms? Not to spend too much time here, but I just wanted to give you a quick update on some of the trends that we see in the data center today that forcing our customers to think about upgrading to the higher bandwidth platforms and eventually us to invest more into 400 gig and even higher bandwidth ASICs and platforms. On the compute side, we see a lot of applications being built utilizing AI and machine learning, which eventually pushes these networks to oversubscription. On the storage side, we see storage becoming more distributed and even network attached. So all these distributed applications, they need to access a big amount of memory and they need to access them fast. Efficiency is another pillar. Our customers are looking to build and maintain sustainable data centers, and they need to do that by increasing their bandwidth and while lowering their power consumption and even rack space. So with that in mind, let's take a look at Cisco Nexus portfolio evolution. As you guys are aware, Nexus has been around since 2008, and ever since we've been adding more capabilities and enhancing the platform, started with 1 gig all the way to our 400 gig announcements in 2018. As you can see in this screen, we actually start shipping the first 9300GX fixed platforms that were capable of 400 gig interfaces back in 2019. And we also released a line card for the existing 9500 platforms. Last October, we actually shipped the first 9300GX2 platform, which gave our customer 32 ports of 400 gig port in a single rack unit form factor. But let's talk about what's new and what we just announced. 2 weeks from now, we're going to ship the first 64 ports of 400 gig and a 48 port 400 gig port fixed 9300GX2 platforms. And those are going to be both the 2 rack unit, and I'll get into the details of each platform in upcoming slides. But in addition to the 9300 switches, we're also introducing 2 new platforms into the 9000 product family. Nexus 9808, which can give us up to 288 400 gig ports. And we're also releasing a 4-slot version of the same 9800 chassis later on this year, which gives us up to 144 400 gig ports in a single system. Now, these 2 systems, the Nexus 9800s, they're also 800 gig ready, which when we release the 800 gig line cards, customers can just put them in the chassis and they're good to go. We're also introducing a new centralized modular chassis. We call it the Nexus 9400. And as you can see, the line cards are actually oriented vertically in this chassis. And customers can get up to 64 400 gig ports or 128 200 gig ports, depending on which line cards they pick on this chassis. Now, even though it's a modular chassis, it's a single ASIC design, which I'll get into that design later on. But there is a supervisor that is built up replaceable, and also there will be a switch line card in the back, which I'll show you in the upcoming slides, which means customers can actually replace the switch modules and upgrade the ASIC as well. Now, at the bottom of the page, you see some of the use cases that these platforms are addressing. On the cloud service providers, as they transition from their existing 10 400 gig server NICs to the 25, 50, or even 100 gig server NICs, they looking to reduce their power consumption per gigabits of traffic. For telco service providers, as they ramp up their adoptions to 5G, they often find themselves oversubscribed in their existing networks. Enterprise customers also, these are the ones that are developed in the AI and machine learning applications. Not only they're looking to increase the bandwidth, but they're also looking to use some of these advanced telemetry features that we have developed in our own custom silicon into the network. And finally, IP Fabric Media customers that they have these 8K uncompressed videos running on the 100 gig endpoints, and they need to upgrade their networks to networks with 400 gig capable uplinks. Any questions before I go to the next page? Good. All right. So let's take a closer look into Nexus 9300 GX2 platforms. These are Cisco's high-density 400 gig fixed switches, and these are the additions to the 9300 series. All of them are capable to operate in NX-OS or ACI mode. And in fact, in each use case, they'll be able to be deployed as a spine or leaf. Because they're powered by Cisco's cloud scale ASIC, they're equipped with all the enhanced telemetry features that we developed so far. That's your flow table event, streaming statistics, or even INT-XT, which is formerly known as INT postcard. Security is a big part of Nexus 9000 portfolio. So all these platforms will support MACsec and CloudSec. MACsec being your end-to-end encryption, and CloudSec is the VTEP to VTEP encryption. Now, the 9348 version is special in the sense that MACsec and CloudSec is supported in all the ports, but the 64 port version will support MACsec in the first 16 ports, and the 32 port version will support in the last 8 ports. That's why you see the yellow color in them. All of these are single ASIC, and the ASIC will support up to 120 megs of buffer, total system buffer, and egress buffer. So let's take a look at the architecture. They're relatively simple system on chip architecture, meaning all the ports are pretty much connected to the ASIC, with the exception of ports that are MACsec capable. For those ports, there will be a MACsec PHY between the ASIC SerDes and the front panel ports. The 96D and the 48D will utilize Cisco's GX2A ASIC, and the 32D version will utilize the Cisco's GX2B ASIC. Now I'll get into the ASIC a little bit at the end, but the LS here stands for leaf spine, meaning it can be supporting leaf or spine in ACI, and the corresponding number is the bandwidth of the ASIC. Now all of these platforms come with standard 32 gigabits of memory and 128 gigabits of storage, which is pretty standard for all of our Nexus 9300. The 2RU chassis, the first two, that will have 4 fans, and the 1RU 32 ports will have 6 smaller fans in the back. Now let's take a look at the 9400 compact chassis. This is our centralized or compact modular chassis. I want to point out that even though we call it the modular chassis, there's no fabric modules in this chassis. It's a single ASIC design. It's actually utilizing the same ASIC that we use in 64 and 48 port 9300 GX2. And we get, again, if we use the 8 400 gig LAM cards, we get up to 64 ports of 400 gig, or we can get up to 128 ports of 200 gig, depending on which LAM card you use. And of course, customers can mix and match depending on their use case. Breakout is supported in all the ports. And again, just because we are utilizing a Cisco Cloud Scale ASIC, all of these enhanced telemetry features are available at 400 gig. Now, the LAM cards that goes in front of this chassis, they all have MACsec PHY. So we're going to be able to support MACsec and CloudSec on all the ports as well here. There is actually a field replaceable supervisor for this chassis and a field replaceable switch card as well. Now, this is a new concept. We usually don't switch the ASIC on the chassis, but in case we release the next generation ASIC and customers wants to utilize the same chassis, they can take out the fans and pull the switch card out. Basically, it's a big giant heat sink. The supervisor is also capable of doing sync-key on top of the PTP synchronization, and we support, the system has 4 power supplies. And this is all in 4 rack units. Now, some of the design advantages that we have with the 9400, it's only 600 millimeters deep or 24 inches, and this is shorter than your 2RU 9300 GX2 because they're around 27 inches. There's the switch card that you saw in the back. You can pull it out. It's a 26-layer PCB design and has a single row of connection to all these LAM cards in the back. The LAM cards themselves, there are 2 flavors, but they all, both of them have a single PCB design. And that's done for less complexity and better reliability. But you can pull it out and you can see the only difference between the 2 are the heat sinks that on top of the 400 gig or 200 gig QSFP ports. Now, if you take a look at the architecture of this platform, you can see each LAM cards will be connected to the switch port via 8 400 gig ports. And even the supervisor connects to the same connector. And if we need to replace the switch port, we need to pull out the fans because fans are on top of the switch port. And again, the ASIC that we use here is GX2A. Okay, so now let's take a look at Cisco's Nexus 98000 series modular chassis, which we just introduced as well. Now, this is a system designed for performance, flexibility, and efficiency in mind. We're talking high port density while we're lowering the power consumption for these interfaces. Actually, if you look at the chassis design, this is the 2nd generation of orthogonal design. As you guys remember, when we first shipped the Nexus 9500 modular chassis, we removed the mid-plane between the line cards and fabric modules, which reduced the cost of cooling and operating this fabric switch significantly. In addition to that, in this version, we also re-engineered the airflow so that the chassis is more efficient for cooling. We get 14.4 terabits per slot. That's 36 port of 400 gig ports. And do the math for 8 slot chassis, we get 115.2 terabits of bandwidth. And for the 4 port, that's, I think it's 56.7 or 57.6 terabits of forwarding in the 4 slot chassis. Again, these are also supporting ACI and NX-OS. And in the first release, we're targeting the spine functionality in NX-OS and ACI. And later on, we're going to build on top of that. Again, security is a big concern in 9K. So we have MACsec enabled in all the ports. So all 36 ports will run MACsec in a line rate. If you take out the redundancy capability of the chassis, obviously N+N power supply, 1+1 supervisor redundancy. But what's unique about this chassis is we get 7+1 fabric module redundancy. And I'll get into that. And also graceful insertion and removal for the line cards. If you take a closer look at the line card itself, it's actually 36 QSFP56DD, which gives us 14.4 terabits of forwarding. As I said, there are MACsec PHYs in the front, so you have MACsec capability. We also support ZR and ZR Plus optics at 400 gig. And if you're familiar with them, those are the high range. You get up to 120 kilometers, and they're used for data center interconnects. Now, obviously, if you use a ZR or ZR Plus transceiver, there will be more power utilized per optic. Now, I'll get into the ASIC for this line card later on, but each ASIC will have 108 megabits of on-die packet buffer, which is fully shared between all slices. And in addition to that, they'll have 8 gigabits of HBM buffer, so off-die high bandwidth memory. That HBM buffer will be utilized for two use cases. First, we're going to use it for packet buffering, so we'll have deep buffers. We also can use it for extending the routing tables, the FIP lookup. All ports are breakout capable. We don't have any restriction on which ports will be breakout or not. And like I said, these line cards will have a 7-to-1 fabric redundancy.
So I've got a question on the breakout part.
Sure.
So these are 400 gig capable ports.
Mm-hmm.
Math says that I should be able to break it out into more than 425 gig ports. Is that just a limitation in the amount of space that it would take up?
Yeah, you're limited to number of SerDes that each ASIC has. So each Q2 Silicon One ASIC has 256 SerDes. So that's where the breakout limitation.
So that math works.
Yes. There's always SerDes. All right, if we take a closer look at the architecture of the line card, like I said, it comes with 3 Q200 ASICs. I'll talk a little bit more about the Q200 later on. Q200s are second generation of Silicon One ASICs, and each one is equipped with high bandwidth memory, and each one provides 4.8 terabits of front panel facing bandwidth, which for 36 ports we get 14.4. And they actually provide 6.2 terabits towards the fabric modules. And the reason why is because we have the redundancy in mind. So more bandwidth towards the fabric modules in case one of them fail. So 19.2 terabits back and 14.4 terabits in front. And if you take a closer look for these connections from each line card to the fabric modules, we'll see that 19.2 terabits is divided to 8 fabric modules, and each fabric module gets 2.2 terabits. Okay. If we take an even closer look, we'll see that each Q2 ASIC will have 1650 gig lanes to each fabric modules. Okay. So why do you have all of that connectivity to the fabric modules? Because we want fabric module redundancy. So the fabric, the line card will be line rate at 14.4 terabits, even if one of the fabric modules fail, because the extra bandwidth towards the back. In fact, the chassis will operate even with 1 fabric modules, right? Let's say all 7 of them fail, it will still operate, but it will be 50% line rate. And if you have all 8 line cards, you can still operate at 115.2 terabits per second, even though 1 fabric module failed, right?
Kind of the intent then be that somebody could kind of start with 2 or 3 or 4 fabric modules. If they're not fully populating it, they're not pushing all the bandwidth through, and then they could add more fabric modules kind of as the load increased? Or would the idea be that you start with it fully populated?
The idea is that you start with it fully populated. Now that's for the 400 gig line cards, but we also have different line cards in the roadmap that would not require all 7 of them, right?
Okay.
So it really, we're talking about 115.2 terabits of bandwidth, and that's why you need. And actually, the cool thing about the fabric modules is that you can, if one of them fail, right, you're still operating 100%. So you can go pull out one of the fans, and you will see which fabric module is behind which fan, and you can just pull the fabric module out, put a new one in, put the fabric fan back, and no interruption to the traffic.
I was actually going to ask about that, because in the picture that you showed, it looked like there was like 4 modules that would come out, and it kind of pointed that the fabric modules were there. There's 4 things, but you're saying there's 8. So was there 2? But it's
no. So each fan will have 2 fabric modules behind it, and you can actually, we have it in the showcase in Water Solution. If you want to stop by, I can show you.
So if you get the fan module there, you pull that fan module out because you're going to pull out one of those fabric modules. Does the other one continue running, or is it like there's an airflow problem, so it'll stay running?
Yeah, I mean, you can put it temporarily to replace
Right.
it. You're not going to have the system shutting down because you pull the fan out.
There's been some Cisco devices that have been a little bit finicky.
Not this one.
when
This one
fans
is-
are pulled.
This one can't even tell you the weather.
So a question about the 9804 and the 9808.
Okay.
Are both of those today certified for IP fabric media? Are they
We actually-
ready to go
so-
for IPFM?
We are targeting those customers first because those are the ones that, hey, we need more bandwidth now.
Need it today,
Yeah,
actually. So,
Yeah,
that-
so
hopefully
those
that's like
cases
top of
are
the list.
prioritized, exactly.
Yeah.
If I may interject for a moment. So at the time when we released them, one of the use case which we'll address first, it's exactly IP fabric for media, because with transition from HD to 4K to 8K to 12K in a later stage, the requirement for higher bandwidth grows.
Right.
So that's main the reason why we need kind of this kind of chassis, which is having a larger number of 400 gig ports with future in 800 gig.
Yeah, I mean, as studios develop, right, and they're stacking multiple studios in one building, right, you're ending up with a very large IPFM need,
Yes.
right? So that needs to be like soon.
Yes. No, it's
Yeah, on the way.
First day when we release the chassis, we'll be able to support IPFM use
Okay,
cases.
okay.
Yes.
We're actually releasing for those customers first.
Fantastic.
Better work.
Thank you.
And, that's part of, as Nemanja mentioned, they're looking for upgrading even further to 800 gig, and this chassis will give them the opportunity to do so. All right, Cisco Cloud Networking ASICs. We actually start shipping the first Nexus 9000 with our custom silicon back in 2016. And you might be familiar with some of these ASICs. You might hear EX, FX, FX2, FX3. But it was with GX ASIC introduction that we started 400 gig capabilities into these ASICs. And actually, those two first platforms that we shipped in 2019, the 9300 GXs, they will utilize the LS6400 GX ASIC. But with the GX2 ASICs, we enhanced the GX capabilities as far as bandwidth and feature set. And so we get 25.6 terabits on a single ASIC with GX2A, which is used in 9400 and 9264 and 9348. And also GX2B, which is eventually half of the bandwidth, but more forwarding features, and I'll get into that. And lately, we add the Q200 Silicon One ASIC to the family, and that's also a 12.8 terabit ASIC. And that's a second generation Silicon One ASIC. Now, if you take a closer look at GX2A and GX2B, I'm not going to say the entire name, but so there's a story behind that. But the GX2A is, it has 4 slice pairs and essentially 8 slices, okay? And all of these 8 slices, they're connected with each other with what we call a slice interconnect, okay? There's non-blocking connection between all the slices and that one, just like any other cloud scale ASIC. We get 512 50 gig PAM4 SerDes, and the chip can operate, it's up 25.6 terabit. And the GX2B version, we don't have slice pairs, but we have just 4 slices, and each slice providing 3.2 terabits of bandwidth. Now, this is the one that is used in Nexus 9332B, and it's half of the bandwidth. But quickly, last 2 minutes, we'll spend on the Silicon One. I can spend a day on this ASIC, but this is just to give you a quick update. It's the second generation. We also have 6 slices in Q200. In addition to slice interconnect or on-die memory, we also have the HBM off-die, which gives us access to the 8 gigabits of memory. Now, there is this, we don't call the forwarding on the slices of forwarding pipeline because they're not really pipeline. They're packet processors. As you guys are aware, Silicon One doesn't have a fixed packet pipeline. It's completely programmable pipeline, so we can reprogram the packet processor. And this ASIC provides 256 50 gig SerDes, and there's actually two versions of this one. In the line card, we use this one with HBM, but for the fabric modules, there is a lighter version. It's called Q200L, which is exactly the same ASIC without the HBM, because we don't need to buffer anything in the fabric modules.
Can you comment about the latency on this platform?
So the latency depends, right? So when are you talking about the ASIC latency, or are you talking about the platform latency?
Platform latency is more concerning to me.
Right. So each time anybody talks about a modular chassis, latency is higher. Why? Because you're essentially going through three different switches. So if the packet is destined in the same slice, you do the switching on the slice interconnect of the line card. You don't even go to the fabric module. So that latency will be significantly lower, if not significantly, but 3 times lower than if you go through the fabric, right? And the latency will be similar to many 9500 chassis, right? We did some testing and it's around the same. And we were talking about 100 gig latency, we talked about 400 gig. There's a whole bunch of latency tests we can do, but expect latency to be higher for two reasons. Why? One is it's a modular chassis, so you go through three different hops. And second, while this is a HBM deep buffer platform, right? Anytime you're looking at deep buffers, latency becoming higher.